Hi everyone and welcome back to my YouTube channel. My name's Amy from Tuition Up and today we have a special guest presenter. This is my son. His name is Roman. Say hi.
Hello.
And we are going to go through a maths paper today. We're going to go through the 2024 SATs arithmetic paper. So please grab a piece of paper and a pencil. The link that you need to download the paper is in the description below and you can join with us. And we do make some mistakes along the way, but
Yes.
we learn from them, don't we?
Yeah,
we
get there in the end.
Yeah, and it's quite nice to do it together because we have kind of different methods. I really like improper fractions. Roman prefers
Mixed numbers.
mixed numbers. Yeah, so enjoy and I hope it's helpful. Okay, so this is the 2024 National Curriculum Key Stage 2 Arithmetic Test in Maths. There's half an hour for this test, so all questions need to be completed and filled in within half an hour. Probably going to take us a little bit longer than half an hour to do it because we've got a bit of talking to do in between, haven't we? But yeah, we'll see how we go. So when we answer these questions, it's going to be a mix of me doing it and Roman doing it. Again, it's not a teaching video, so I'm not going to kind of go through the explanation of everything, but we might have some discussions along the way. Okay, if you want to do it along with us, if you look in the comments, there is the paper to download and you can stay with us as we go through it and work alongside. Okay, let's start then. So how would you do this one?
Column addition.
You do column addition? You wouldn't do any mental methods with this one?
If I didn't have any paper, then I just round 689 to 690 and add it and then take away one from the answer that I get.
So would you, okay, so you, or would you round that to 40 as well?
No, I wouldn't round them both up, just one up.
And then I'd take away 3? I would. So let's do that then.
Okay.
So 9, what's this? 13, 6, 7. Yeah, okay, all right, good. That's that one. Right in the box. Correct, 1 mark. Brilliant. Next one. Pretty self-explanatory, these first ones, aren't they, really?
They are a bit.
Quite easy, aren't they? So this is the ones you can speed through really quickly and get the answer. Agree?
Agreed, yes.
Okay, so this one, what would you do? How would you do it?
I just do column subtraction.
Column to subtraction. Let's do it then. So checking that we've got each digit in the box. You don't need to do column subtraction. Can you not do a mental method for that?
I can.
What would you do for a mental method?
I'll just round the 19 up to 20.
Yeah.
So it become 4,512, and then add 1, so it becomes 4,533. No, 13. Sorry.
13. Yeah, that's the right answer. Great, well done. Number 5. How would you do this one?
I do
3 times 391. Okay, you do it massive. That's okay. It's fine. I think if you were doing this on paper, you would keep your digit into the box, wouldn't you? But obviously, it's really hard because we're using one of these writing tablets that Roman's not used to. But you're doing a great job. 9 3s. Good. That's a 27. Good. And then into the box, 1,173. It is the right answer. Good stuff. Well done. Okay. Oh, they do it like this sometimes, the other way around, don't they? To trick you into kind of confusing you. They have the answer at the front, which doesn't really matter, does it? Okay, so me doing this one. 1 take away 0 is still 1. 7 take away 3 is 4. 1 take away 5 we can't do, so we're going to take from here. So 11 take away 5 is 6. And then 8 take away 0, we still have the 8 there. So it would be 8,641. Agree?
Agree.
As he looks at the answer sheet.
We don't have an answer sheet, do we?
Oh, this is a great one to do. Okay, number 7, 6,600 divided by 6. Over to you, Ro. How would you do it?
I think it's a bit far-fetched to do the whole...
Yeah, it is, isn't it? You don't need to do it at all. So don't bother.
What I'm going to do is that, but I don't need to do that because I know it's 11. So it will just be
1,100 100. Yeah, these are the ones that you can kind of whiz through quickly because you can see straight away, can't you, that it just goes into it once. Okay, great. Super speedy. What about this one then? Ooh, this is a nice one. 99 times 10 times 1.
The 1 doesn't matter because it will just keep it the same. So all we're worrying about is 99 times 10. And when times in by 10, you just place a 0 on the end and shift all the digits to the left once. So that means it will become 990.
Yeah, so I would just say it's slightly different. I'd say remove the digits first and then place the 0 on afterwards. Yeah, so it will be 990. Perfect answer. Well done. Very good. Okay, question 9. Let's have a go of this one then. Let me get the little pen. Question 9, 7.68. Let me get the little pen. 7.68 add 13.493. Going for the biggest number first. Very good. So the important thing is here, what do you think is the key thing where people go wrong in this one? What do you think people do?
If they don't put in the extra digit, they'll put the 0 in there and they just somehow mess up doing that.
Yeah, it's about getting that decimal in the right place, isn't it? We need that decimal point in the right place, otherwise it all goes wobbly, and we need those placeholders in. We could even do those placeholders in different colors, couldn't we? Yay, awesome, well done. 21.173. Happy with that?
Yeah.
Oh, interesting, this one actually. Because you could times it by 10 and then take away 700 and...
Yeah, that's what I was thinking about doing, but honestly,
it's probably just easier, isn't it, just to stick it in?
Easier to do a multiplication.
2 9s are 18, 5 9s are 45, 46, 7 9s are 63, 63 add 4, 67, yeah?
Yep.
So 6,760. Yeah, I'm glad you're happy with that. I am too. Excellent. We just can put our comma in there. Okay, good stuff. Well done. You can't see, but he's clapping my leg, because I've got it right, which is nice. Right. Okay. Next one. How are we doing this?
Because it seems a bit long to do 640, and I know if you just got rid of the 0 and crossed out the 0, then it will become 64, and you can divide 64 by 8, which means 8, but then we've got to place the 0 back in, so the answer would be 80.
80, yeah. 8 8's a 64. We know that, don't we? I think it's, what is it, year 4 by the time you need to know your 8 times table. Yeah. So it's 80, yeah?
Yeah.
Lovely, well done. Okay, number 12. Subtraction. You want to do this one?
Yeah.
Okay, go for it.
I added them.
You added them.
I added them.
You added them.
Can you get rid of
what made you notice that you added them?
Because when I was putting it in there, I know that this here needs to be, the answer there needs to be smaller than this number here. So that's why I.
So then you knew, you're like, oh, I've got a bigger number, so I've done it wrong. Okay, well done. Yeah. All right, great. We keep mistakes in because mistakes are good. Lovely. Okay, so let's do the right thing this time.
Okay. So
it just shows you've got to read it really, really carefully. Yeah, do it down there. Just got different ideas on things. Okay.
So I got 268.
Yeah, it's the right answer. So well done. Yay. Both methods work. So yeah, just to go over that, I would I would cross this one first and just do it step by step. But yeah, as long as you're getting the right answer, there's loads of different ways to do maths. Okay. Number 13. 561 divided by 3 goes in once, 2. How many 3s in 26?
8.
Remainder?
2.
and
then
7. Yeah, good. 187. Perfect. Oh, you want to do the next one? Or you want to do the next one? Okay, cool.
This one was in our SATs, mock SATs paper.
Was it?
It wasn't the exact one, but it was the one like this.
Yeah, there's always one of these.
When you're multiplying fractions, you need to times the top number and then the bottom. You need to times the numerators and the denominators. So first of all, it's 4 times 1, which equals 4.
Then
so then the top will be 4, and then it's 6
denominators
times 8, which equals 48, and so it'll be 4 over 48, but you can simplify that down to 1 over 12.
Yes, very good. Well done. Great knowledge of times table facts there to help you with that. Actually, just checking the marking scheme there, you would actually get the mark for that.
Mr. Lambert keeps telling us that during the in year 6 you don't have to simplify, but in year 7 you do.
Yeah.
I would get that
That's
wrong
true
in a test.
No, you wouldn't get that wrong.
No, I would get that wrong if I.
In year 7. Yeah. Okay, cool. Good stuff. Well done. I'm enjoying this. Right, we're on number 15. Oh, it's another division. So many division in these, aren't there? Right, what about this one? Do you want to do
it? Okay. We don't need to do the 0 because I know you can divide. I know you can fit 7. I know you can divide 63 by 7, and 63 by 7 is 9. But then you got to add place a 0 back at the end of 9, so it'll become
90. Yeah, just stick it in the box. Yeah. Good. Your 9s really bother me.
Sorry.
So I always do a 9 like that, around like that, and you do it woo like that.
Yeah, I do.
Okay, cool. Doing really well. It's great. I'm going to do this one. Can I? Because you've done loads. Let me do this one. Okay, so we've got place value question here. We've got millions, and we've got the answer here. We've got add. Oh, we've got 3 little parts to this. So we've got to work out basically what would go in here. So we've got the 70. I've already got that there, and I've got the 6 million. And the only thing we don't have is the 20,000. So that would go in here, just like that. I'm not really sure what I would put in this box, really. It just seems kind of a bit of wasted space. I guess you could write out the whole thing and kind of split it up, but it reminds me of those. Do you remember those arrow cards you used to look at and place them over? Yeah, it's just like one of those questions. Okay, good. Question 17. I'm going to do this one too. No, my turn. Okay. 2,671 times 1,000. Oh, really good. So we have to just move the digits along 3 places to the left. Okay, so you're going to have to kind of picture the digits going over. Some people might find it useful to write out a place value chart here, but some people could probably just jump it in their head. So let's just work it out and see if we agree. So we're going 1.
Sometimes with really big numbers, I can do it in my head like that, but sometimes with really big numbers like millions and tens of millions, I write down the number without any decimal points in it or any commas, and I just place the zeros on the end, and then I put the commas back in. And
okay, have I got that right?
Yeah.
Okay, so I need to pop it in here though, don't I? Otherwise
it's not going to fit.
It's not going to fit. Question 18.
When you're adding fractions or subtracting them, to be fair, you need to make the denominators the same. And with this one, it's a bit easier because you only need to times one denominator. You only need to get the one denominator to the same as the other one. You don't need to times them to get
because
together.
They're both in the 3 times table.
They're both in the 3 times table.
So we're looking for the lowest common multiple of both of them, which is 12.
So you need to times 3 by 4 to get to 12.
Okay.
So that means what you do to the bottom, you do to the top, meaning that it will become 5 twelfths, add 4 twelfths, which is 9 twelfths. And you can simplify that down to 3/4.
Or 3/4. Awesome. Very good. Another add?
Can I do this one?
Yeah, go. You talk it through, and I will. I'll write it down.
So this one, unlike the last one, they're not both in the 3 times table.
What are not?
The denominators. So you have to find the lowest common multiple, and if you can't do that, then it is okay to just times them by each other, so they become 15ths.
Oh,
so
good.
If you times the 2 thirds, you got to times the bottom by 5 and the top by 5, meaning it will be 10 15ths, and then you got to times 4 fifths. You got to times them both by 3, meaning it will be 12 15ths, so it will be 22 15ths, and that's
what did you say for this one?
10. And that's an improper fraction, so you've got to make it a mixed number, and the mixed number would be 1 7 15ths, which I don't think you can simplify.
Yep, you can't. Well done. Perfect. Okay, but you would be able to have an improper fraction accepted as an answer there. I actually really like improper fractions.
I don't like them too much.
You prefer mixed numbers, do you? Oh, really? Okay, no, I kind of feel the improper. I know it almost doesn't feel like it's finished off somehow, does it?
Yeah.
Yeah, so here we're looking for the lowest common multiple. A lot of children would go wrong here and put 12 as the lowest common multiple. I've seen that a few times, but yeah, it is actually 15. Lovely. Oh, he's begging me to let him do this one. So.
Please.
Gosh, begs me for
maths. I love these.
There you go. All yours. Let's move on and see what joys we have next. Oh, I like this one.
Do you want to do it?
Yeah, this is the BIDMAS or BODMAS, orders or indices.
It stands for BIDMAS is the B is the brackets. If you put brackets around a operation, then it means it does it first, and then the I is for indices,
or it used to be called orders when I was so we called it orders. BODMAS.
And then and that is like squaring and
cubing, which we have here.
And then the D is division, and then and the M is for multiplication. But if you've got say a division and a multiplication in a question,
yes,
then they are the same.
Yes.
So you just read from left to right.
Yeah. So when I've seen it done like this, is a really important point. I've seen it put in a pyramid like this, and I think sometimes it's kind of better in a pyramid, because then you see the D and the M on the same line, don't you? Yeah. And it's a very bad little drawing this, and a little addition and subtraction. You just do it in the order that it comes. Yeah. But a lot of people confuse that, and they would go wrong with that.
Oh yeah.
Okay, so what we're going to do is we're going to cube this 3. So we're going to do 3 times 3 times 3, basically. So 3 times 3 is 9, and then the 9 times the 3 is 27. So this is actually 27. So let's do it. You wouldn't take the time to write it all out, really, because you could see straight away that it's 29. Okay, I'm going to do the next one, please. Okay. Is that all right? Yeah. Okay, so we've got 15.5. divided by 100. Just a note on the pen as well, I am using red, and that is not allowed. If you're in your sat, it has to be blue or black, but I'm just doing it so you guys can see. So we're dividing by 100, and I've been doing this a lot with my classes recently. It means we need to move the digits 2 places to the right, because we are dividing, so the number's getting smaller. So so it will be 0.155. What do you think about that one?
Yeah.
Can
I do this one, please? It's BIDMAS, the next one.
Oh, it is a BIDMAS. We've got a bit of a BIDMAS theme on this bit, haven't we? Again, a place value chart could be useful just to jot down for that. Because obviously all those things in sats on the walls and things in classrooms are covered up. So you can just make your own. Right, here we go.
56 divided by 8, which is 7, and then 90 take away 7, which is 83.
Yeah, good. 7 8s are 56, aren't they? Lovely. Perfect. Good stuff. Love a good BIDMAS, don't you?
Yeah.
Oh, this is a nice one. Shall I demonstrate this one? Yeah.
Okay.
So we've got 63 minus 5.8. So what we have to do here is make sure that when we write it out, we have those decimals in. And here we need a placeholder because this one doesn't have a decimal. So we're just going to stick one in. Okay, so our operation, let's get it right, is a subtract. Ding, ding.
Oh, I don't do it like that. I just cross out 6.
I know this is the different way, isn't it? 7 5 27. What do you think?
Yeah, that's right.
Yeah.
Show
your method.
So 7 times 8.
Well, let's keep going. Plodding on. Right, subtractions.
Oh, can I do this one?
Yes, you can do this one.
So, because they're both in the 7 times table, it's pretty easy. So, all you need to do is times the 7 by 3 to get to 21. So what you do to the bottom in a fraction, you've got to do to the top, meaning you've got to times the 6 by 3, making it 18. So then 18 21 take away 11 21 gives you 7.
Yeah, so 7 over 21.
Yeah, and 7 over 21 is 1/3.
1/3. 7 tenths, and we're going to divide it by 2. Help me out.
So when the fractions, the bigger the denominator, the smaller the fraction.
The part, yeah.
Yeah. So if you're making a fraction double the size, you would half the denominator. And if you're making it
triple the size, with third the denominator.
Yeah. But if you're
what do we do here?
If you're making it small, if you're dividing by 2, for instance, you'd have to times it
multiply
by 2.
It, yeah.
So that means it'll become 20. So 7 over 20, which cannot be simplified.
So it's the answer, yeah?
Yeah.
Okay, good stuff. Well done. Nice answers. Nearly there. Oh, okay, so we've got another one. So we've got an integer. We've got a whole number here. Oh, I bet we do this in different ways, because I'd make that an improper. 2 8s are 16, 17, 18, 19, yeah?
Yeah, 19
over 8.
Take away
5 over 8.
Which is 15. No, yeah, 14 over 8, which is 1 and 6.
1 and
yeah, it's 6. Yeah.
Yeah, 1 and 6 eighths.
1 and 6 eighths.
Yeah. Okay. Good. So either as an improper or a mixed number.
Can I do this next one, please? Please.
Ah, look.
Trust. We
can simplify it.
Oh, yes, we can. So we can divide them both by 2, making it 1 and 3/4.
1 and 3/4. Yeah. Yeah. Okay. All right. Good. All of those would be acceptable answers, though. But you get 3 for the price of 1 here. Oh, yeah.
Can I do these next 2, please?
Okay. Sure.
I factorize.
Okay, factorize away.
So instead of doing a big mean number like that, I do 2.
So why have you chosen 2?
Because 2 can fit into that easily, because you've basically got to abort it if you get a remainder on your first one, because that's just really hard to do. So if you choose something that can fit into the first number, then that would be good. So 2's into 9 is 4.
Mm-hmm.
Remainder 1.
I tell you what, let me write it. You talk the maths.
And then 2's into 8 are 18 or 9, and then 2's into 6 are 3.
Mm-hmm.
So now we do the 17. 17 can't be factorized.
So just tell everyone why you've got 17.
Because 2 times 17 makes 34.
Yeah. So these are the
factors.
These are the prime factors, aren't they?
Oh yeah, prime factors.
Prime factors of 34. Okay. Right. So 17. What we're doing here?
So 17 divided by 493, because that's what you got for the past.
So 493 divided by 17. Yeah.
So 0 17 is going into 4, so we carry the 4 over to 49, and this is where I'd start listing it. So it'd go to 34, and then to 51.
Mm-hmm. Oh, these prime numbers.
Yeah, I know. And then to 68. We don't need any more for the moment.
No, we're all right.
So 49 is 1, 2. So 2, remainder 15. So we carry the 15. So now we gotta. So then the next in the times table would be 80. I think
85.
85, and then 102, and then 119.
Keep going.
And then 139. No, 136. That's it.
One more.
One more. Yeah, that would be 153. So that took 1, 2, 3, 4, 5, 6, 7, 8, 9. So it took 9 to get there. So 29 would be the answer.
Wow. What an awesome method. Okay. Right. Nearly done. Oh, percentage. Oh, yes, please. No, I want to do it. I want to do it. Okay. How would you do it then? Go on, let's see if we do it in the same way. Would you find 10% first?
What I'd do is I'd find 10. I'd probably do find 1%, which is dividing it by 100 and then times it by 99.
Okay, perfect.
Maybe we should just
9.
So that's 4 ends in 4, and put the 5 down there.
9, 6,
and then 9, and then 9 goes there.
59.
9 goes there. Yeah.
Woohoo!
Yay!
Lovely. I really like those.
Yeah.
Okay, half divided by 3. How are you doing this?
So 1/2 would obviously is bigger than 1/6, than 1/3. So the bigger the denominator, the smaller the fraction. So all you need to do is times the denominator by the number you're dividing by. Please.
Why do we both love percentage ones?
Use the last one. So I would find
10%.
Yeah, 10%. I'd find 10% and then times it by 4. So 10% would be 90.
Because we've done it 900, yeah.
And then 90 times 4 is a bit hard. So instead we could just do 9 times 4, which is 36. And then we've got to put the 0 back. So it's 360.
So we're at 40% now, aren't we?
And then we could find 1%, which would be 9. And then 3 times 9 is 27. And then 27 add 360 is 87.
High five.
No.
It's correct.
How? Oh, high five.
You have me looking at the answers there. Yeah. Cool. And Nearly there. We're nearly on the last page. Oh my goodness.
No.
I wonder how long it's taken us actually.
Same. Or can I please do this fraction one? You can do
Oh, okay. How are you going to do this?
39.00 take away times by 1.25, and then the 5 times, draw a line then, and then the 5 times the 0 is 0, and then the 5 times the other 0 is 0, and then the 5 times the 9 is 45. So you put the 4 down there and the 5 up there.
Yes. So we've got 4 decimals in the question. So we need 1, 2, 3, 4 in the answer. Yeah. In the answer, they've put it as you could do it as a fraction, couldn't you? So you could say 48 and 3/4. And it probably would be best practice because with the question has been in a fraction. Yeah, but it wouldn't matter for the answer. Okay, all right, good. And we're going to end with this one. This is the final one. Hip, hip, hooray. Maths, you've done enough maths this weekend, haven't you? This one, shall I just write this one out as it would be for a long division, just so people who don't know the other, we're yawning right at the end of it. I'm just going to write out the answer of what it would be if we were doing the long division method. Okay, I don't think everyone wants to sit through a long division method. You're yawning. Here's the end of the arithmetic paper. Okay, thank you for watching. Amazing.
Because
you got a few wrong
that I got right.
But you got loads more wrong than me.
Yeah, but so what? I did more questions than you.
You are very good. Well done. Excellent. Oh yeah, there's an 8 at the front. Right, let's do that again.
Edit that out, yeah.
Edit that out, yeah. So we've got to edit these two.
You.
Honestly, me. Oh my gosh.
Tut.
Tut tut. It's wrong, isn't it?